Welcome back. Today we're going to talk about integrals of this form. A plus infinity f of t dt or minus infinity b f of t dt. These kinds of integrals are called improper integrals. To be able to define these ones, we need to have, let's say, we assume that f is positive in this case. So we assume that the integral between a and x f of t dt exists for all x bigger than a. The same thing here. So let's say we're integrating this function between, let's say, between x and b. We assume that this integral between x and b of, let's call this one g of t dt exists for all x less than b. So if it does, then we can define this integral as the limit as x goes to infinity of the integral between a and x of f of t dt. So this is what we mean. And this is called the integral of the first kind. We deal with infinities, okay, in the bounds. The same thing here for minus infinity b f of t dt. It's gonna be the limit as x goes to minus infinity between x and b f of t dt. Okay, for instance, we can find this integral 1 over t dt. So the limit here is defined as x goes to infinity between 1 and x of 1 over t dt. And we know that this one exists for all x bigger than 1. So therefore, the limit as x goes to infinity of the natural log of x. And this is infinity. Okay, so we can give some meaning to this one here. So we know the natural log, okay? So it's always positive when x is bigger than 1. And here, the integral between 1 and plus infinity is this area, which is infinite. That's why we say this one is divergent. If this limit is finite, we call the integral convergent. If it's not, we call it divergent. The first kind of improper integral, because we have this infinity here. So that's the difference between the first kind and the second kind. We're gonna see what we mean by the second kind. But first we deal with infinity. For instance, we can see what we can have between 1 and infinity of 1 over t squared dt. So we define the limit as x goes to infinity between 1 and x of 1 over t squared dt. This one always exists for all x bigger than 1. And we know that as x goes to infinity, we can compute this one as minus 1 over t between 1 and x. So it's just 1 minus 1 over x. Okay? And when we take the limit as x goes to infinity, we get 1. Okay? That means the area under the graph between 1 and infinity is just 1. It's finite. Okay? That's what we in this case, that's how we interpret this infinite integral. The most important thing to take is that the integral should exist on any small interval. And after that, we take the limit. We take the overall picture. We take the integral between a and x, we compute it, and we take the limit. So this is the definition here. So this is what we mean when we define the improper integral of the first kind. The same thing here for infinity, okay? So you need to keep this one in mind because we're gonna use it a lot.